So let us start with lesson 6 and talk about Azure Management Services. You can manage and monitor your Azure environment by using both built-in Azure utilities and other management products, not designed specifically for the public cloud such as System Center. This lesson outlines the primary management services and methods available for Azure and explains how you can use them in your environment. After completing this lesson, we will be able to describe the Microsoft Operations Management Suite. We'll be able to explain how we can track events and collect diagnostics in Azure. And we'll be able to explain how to manage accounts, subscriptions, and administrative roles in the Azure Management Portal. Let us first start with OMS. That is Operations Management Suite. So OMS is a Microsoft cloud-based service that delivers enterprise-wide monitoring and management functionality for on-premise and cloud-based resources from a single console. Its capabilities span several functional groups, including operational visibility management, which helps in proactive smart alerts, operations dashboard and reporting, real-time customizable reporting as well. There is a functional group called as security, which provides security log collections, breach and threat detection, and forensic analysis. Then there is a functional group called as performance monitoring and analytics, which is a resource monitoring for Windows and Linux. It helps in on-prem server performance monitoring, it helps in Azure server performance monitoring, and SAN storage analytics. Then you have a functional group called as log management, which helps in universal log collection, analysis, virtually unlimited data retention, and a dashboard powered by search queries. Another functional group is capacity planning, which helps in forecast of resource utilization trends, virtual machine placement optimization, the identification of storage bottlenecks. And you have automation, which provides with virtual machine provisioning, app deployment, a runbook gallery, a graphical designer. You have configuration and change tracking, detection, which helps you in detection of configuration issues, identification of deviations from best practices, monitoring of software, tracking of group policies, and file changes. Furthermore, how do you go ahead and work around with OMS is first by signing up using OMS and creating a workspace. Then you add solutions or negate solutions from that particular workspace. After that, you go ahead and connect servers directly to workspace, connect servers to workspace by using System Center Ops Manager, and connect servers to workspace by using diagnostics. And then you go ahead and do all these analytics. Basically, you can collect logs from your data sources, you can do backup, site recovery, configuration change tracking, etc. And then you can use these collected data to analyze by using solutions and your custom searches. Then you have logging and diagnostics in Azure. You can use several different built-in methods to monitor operations in Azure. 1. Activity log. Azure records all write operations, which include put, post, and delete actions in the subscription-wide activity log. The log provides information with the level of event. For example, it might just be something to track information or something that has gone wrong that you would want to know. That is, for example, error. It provides with status. The final status is typically succeeded or failed, but it might also be accepted for long-running operations. Then it also provides you with a timestamp, the user or service that initiated the corresponding event, and the correlation ID of that event. This is basically a unique identifier of that corresponding operation. You can filter audit log events by subscription, resource group, resource type, or specific resource. You can access the log from Azure portal by clicking the activity log entry from the blade of your subscription, each of its resource groups or individual resources within each resource group. For a more thorough analysis when dealing with large number of events to analyze, you can also go ahead and query events using Azure PowerShell, Azure Command Line Interface, or REST API. You can save events to a storage account. This will allow you to specify retention time beyond 90 days that applies to default activity logs. You can use Power BI Content Back to analyze logs in Power BI. You can stream logs to an event hub for ingestion by a third-party service or custom analytics solution such as Power BI. It is also possible to trigger an email notification or a webhook call in response to a specific event. Then you have Azure Diagnostics. Azure Diagnostics allows you to collect diagnostic telemetry data from services running in Azure. The telemetry data is stored in an Azure storage account and can be used for debugging and troubleshooting, measuring performance, monitoring resource usage, analyzing traffic, and capacity planning and auditing. In case of virtual machine, Azure Diagnostics allows you to collect telemetry data by default. That includes Microsoft Internet Information Service logs, Azure Diagnostic Infrastructure logs, IIS failed request logs, Windows event logs, performance counters, crash dumps, custom error logs, .NET event source logs. So this is what comes under Azure Diagnostics. The final one is Matrix. Matrix is a type of performance counter that Azure collects depending primarily on the resource type. For example, in the case of Azure Virtual Machine, Matrix will include disk input-output, network input-output, and CPU utilization, and they are collected on the VM level by default. Furthermore, network will have a different set of matrix, storage will have a different set of matrix, and every other source type will have a different other matrix. Let us now move forward and talk about Azure Access Management. So, in Azure account, there are different ways to control and delegate access when managing Azure resources. To comply with the principle of least privilege, it is important to understand the difference among account, subscription, and administrative roles in Azure. An Azure account determines how and to whom your Azure usage is reported. A subscription helps you to organize your access to your cloud services and resources, and also to control how your resource usage is reported, billed, and paid for. Each of your subscriptions can have a different billing and payment setup. As a result, you can have different subscriptions and different plans based on criteria such as department, project, or regional location. Every Azure resource belongs to a subscription. There are various administrative roles provided in Azure. First one is account administrator. Each account has one account administrator. The account administrator has the authority to access the Azure Account Center, in which he or she can create subscriptions, cancel subscriptions, change the billing for a subscription, and change service administrators, among other tasks. The second one is service administrator. Each Azure subscription has one service administrator. The service administrator can access all resources in the subscription. By default, the user account associated with this role is the same as that of account administrator when your subscription is created. And third one is co-administrator. This role has the same function as the service admin, but it cannot change the association of subscription with an Azure AD tenant. The account administrator for a subscription is the only person who has access to Azure Account Center. Account administrator do not have any other access to services in that subscription. So account administrator 1 per subscription, service administrator 1 per subscription, and co-admin as also a limit, that is 200 per Azure subscription. Then you have role-based access control. Azure provides role-based access control for granular access to resources within an Azure subscription. By using RBAC, you can separate duties within your teams and grant users only the level of access that they require to perform their jobs. Azure RBAC has three basic roles that can apply to all resource types. One is owner, which has full access to all resources, including the right to delegate access to other users. You have contributor, which can create and manage all Azure resource types but cannot grant them access. Reader can view existing Azure resources. So the rest of RBAC roles in Azure allow the management of specific Azure resources. For instance, the virtual machine contributor role allows the creation and management of virtual machines but does not permit the management of virtual network or the subnet that the virtual machine is connected to. You can also create your own roles for role-based access control and define access for the roles according to your own needs. So with this, we come to an end to module 1, and we had a good introduction to Microsoft Azure. Now we will move on to module 2 and we will go ahead and discuss about how we can implement and manage Azure networking.